Hi folks, so in this video what we're going to do here is complete a question from the topic of ellipses and parabolas, otherwise known as conics, and the question itself actually is an old junior cert higher level question based on ellipses and parabolas. It was before the course changed to the current graphic syllabus. So it says here, the figure shows the design of a logo for a sailing club. The curve AB is a parabola with vertex at A, so they tell us here that the curve AB is a parabola with the vertex at A. In this case it's actually a semi-parabola because it's just half. The curve CDG is a semi-ellipse. C down to D all the way around to G is a semi-ellipse with focal points F1 and F2, so we're told F1 and F2. Determine the major and minor axes and draw the semi-ellipse CDG. So that's what they actually tell us to do at the start. That's the first step. They want us to get the major axis and draw the semi-ellipse. Then it also tells us the line EH, from E to H, that line there is a tangent to the semi-ellipse CDG at point E, which is 24 millimeters down from the major axis. The curve LM is an identical portion of the semi-ellipse CDG, okay? And then complete the given design showing clearly how to locate point M. Okay, so what we're going to do is we're going to start off by drawing in the semi-ellipse to start off. So you'll see here, if we look at this guy here, that's the semi-ellipse going from C to D to G. First of all, can I identify any distances on it? I can clearly see from C into the middle is 75 millimeters. Therefore, that's my radius for my major axis. My overall major axis is 150, 75 times 2, but I only need the radius for the semicircle at the bottom. And then I'm also told the distance from the middle to the either focal point, which is 67. So it's from the middle, it's 67 to F2 and 67 to F1. And from that, we'll work out then how to get our minor circle to be able to draw ellipse. So on your page, you'd set up the page like this, keep it low enough down out here on the page. And what I'm going to do is, starting off, I'm going to pick the point right in the middle. I'm going to measure 75. I'm going to get my compass and I'm going to draw in a semicircle. So using this as the center, radius out as far as 75, and we're going to draw in our semicircle. So there's my semicircle, okay? Now, from the center, it's a distance of 67 to either focal point. So if I measure 67 to the right and 67 to the left, I have now found both of my focal points. And I usually do like to identify them and label them. So I'll zoom in here a little bit so it stands out a little bit more. So this one here is called F1 and this one here is F2. Now, rule of thumb here, we're not given the distance down to the minor axis, we're not given the distance down to D, we're not told that distance, so we have to discover it ourselves. But what we do know is, because the major axis is horizontal, the minor axis has to be vertical. And one way we can use and find out the minor axis is, we can take the principle of how we initially find focal points, which is, if you take half the major axis and you swing it from the top of the minor, you can find the focal point, so we can apply that in reverse. If we take half the major axis and we swing from the focal point, we can find the minor. And where it cuts right through there, that is going to be my radius for my minor circle, or in this case, minor semicircle. So I'll put that in there now. So, little principle that often comes up in the new junior cert as well. If you take half the major axis and swing it from the top or bottom of the minor, you can find the focal points. Or if you take half the major axis and swing it from the focal point, you can find the minor. Vice versa. Now that we have that done, what we're going to do is we're going to construct our semi-ellipse. So we're going to go 30 degrees and use the concentric circles method, sometimes called the auxiliary circles method. 30 degrees, 60 degrees, when I'm inside in school, I explain it like pizza slices. And rule of thumb here is, where it cuts the minor circle, we go parallel to the major axis, which means we're either going to go left or right. So here, I'm going to go left, from over here, right, left, and right. And then where it cuts the minor, or the major circle, I'm going to go parallel to the minor axis, which is going vertical in this case. And there we go. And what I'll identify then is all the points on my elliptical curve. There, there, there. At the end of the minor axis is a point, and at either end of the major axis. Now what I am going to do here is I'm going to label this point G. That's point G. This point here is point D, and I've got point C out here. Okay, so now what I can do is I can measure out, okay, I can actually heavy in this line, looking at it here, yeah. So we'll heavy in that to there, and then I'm going to sketch in my elliptical curve as neatly as I possibly can. Take your time. You can see here I'm using the pencil. And go over it in the marker. So you do get marks for the quality of your ellipse. Okay, there we go. Now I will heavy that in a while. Now the next little bit that I'm going to actually focus on, okay, is just this little bit over here. I'm going to get the tangent. I'm going to work out on that, and then I'm going to focus on the parabola. So you'll see here from G, it's a distance of 15 millimeters out here, and we don't know how far down H is yet, but I do know how to find E. It's a distance of 24 down from the major axis. So from the very end here, I'm going to measure a distance of 15 millimeters out. Okay, find that. And that's going to show to me this little part of the boat here. Okay, I've got that. I don't know how far it goes down. Actually, sorry, if you look at the drawing, apologies. From D, you can see where it clearly ends over here. Just like that. Okay, that clearly ends over there. So, from D, if I bring a line across, and do that, and we can clearly see then, okay, from the focal point it's going to go perpendicular to find this, but I don't know that distance yet. Now I have to find my tangent. So I need to find the point of contact, which is point E, down 24. So if I measure down 24, I'm going to use the vertical line I already have here. Measure down 24 millimeters. I'm going to do a line across where it cuts through the ellipse. Should help me locate point E right there. So I'm going to label that point E. That's where I know my point of contact for my tangent is. Now the method for constructing a tangent is this. If you join either focal point, and I always extend it on through E, so join F1 to E and extend it on, and F2 to E extended on, what you've created is two intersecting lines, but you've essentially created four angles between those lines. You've angle 1, angle 2, 3 and 4, and the angle I want to bisect is this one, because when I bisect it, it will give me the tangent. So I'm going to bisect the angle between F2 to E and this line here. So I'll put my compass on E, swing an arc, and an arc, and swing an arc into the open space. From this point, an arc into the open space. And then I can draw in my tangent. Okay? And I know that line is a heavy line. From there to there. Now I can identify this bit here and this bit here. And now what's important to note in regards to getting the bottom of it, we can clearly see that the angle in here is 90 degrees perpendicular, so I need to go from F2 perpendicular to my tangent to get that line there. So little handy trick here, if you use the 45-degree set square. If you take your 45-degree set square and you put it on the line you want to go perpendicular to, I'm going to zoom out here a little bit more. I'm going to take my 45-degree set square. I'm going to put this side of the set square on the line I want to go perpendicular to. I put it on the line like that. If I take the other set square and I put it underneath it, and all I want to do is I want to slide it along. So look, I'm going to slide it along until it gets to the other side of the set square, gets to F2. Now I'll bring it down like that. And there we go. And now I can draw in my line. And there we go. We have now figured out, I'm going to call it the tail of the ship. And at this point here now, I am going to heavy in my curve. Taking my time. Trying to be as neat and as tidy as I can. And there we go. So I've now figured out the bottom of the shape. The next bit I'm going to work on to is the parabola. Okay, so for the parabola here, which is this guy here, the curve going from A to B, anytime we do a parabola, we have to fit it inside of a rectangle. And if you look here, from the major axis, I can see that the height from the middle, from D, it's up 110 as far as A. There's a little measurement in here, and I can get that because I can see that that measurement, it has to be 5, because from the top here down to the triangle part here, there's obviously a little sail here at the back, that's 105 down. So that gap has to be 5 there. Okay, so to get my parabola, I'm going to go up 110, mark 5, go across, and it's in line with C. So I need to make a rectangle from there. Okay. So, I'll zoom out here a little bit. Just this. So, from the middle here, I'm going to do a line up. And from C, I'm going to do a line up. I'm going to measure a distance of 110 up. So, just taking my set square here. I'm going to go from 11 up as far as 0. And while I'm at it, I'm going to measure 5 millimeters up as well. Okay. Line across there. Line across there. And I'll rub out the excess so it doesn't confuse anyone. Okay. So my parabola has to fit inside of that section there. Now I've got points A and B up here. There's point A. And I've got point B down here. Okay, so when I have a parabola this size, I would generally split it up into maybe 5 sections. 4 is probably minimal, but when it's about this size, I would say 5 would be best. So I'm going to split up the vertical line here on the outside. I'm going to do 5. So division of line, if you draw a line out at any random angle and do 5 increments that are the same, so I'm just going to do measurements of 10. So with the 50 on it, I've gone 10, 20, 30, 40, 50. I join that up to the end of the line up here. And then I do a little bit of sliding set squares. So, sliding set squares. Okay, so I've divided that line into 5. Now I have to divide the top line into 5. Same principle. Do a line out at a random angle. Adjust that there. Do 5 increments of 10 on that line. Doesn't have to be 10, it could be 5 20s. I usually just go with 10s. Okay, the very last one, join it to the end of the line. And once again, a little bit of sliding set squares. There. Okay, having done that, now what we're going to do is project these guys down, because they're parallel with the axis, which is going from A. A is where the vertex of the parabola is. And then all these points here on the side where we divided up the line, every one of them joins to A. The first one connects to A, second one, third and fourth. Okay, and what they'll help us locate is points on our parabolic curve. B is a point, and now from A, if I go out one and down one, that's where the next point is. From here, over, down, over, down, over, down, and finally over, down. There's my points. Okay, job here from this point is going to be a case of drawing in the curve like the ellipse, nice and smooth. So I'll go with the pencil first. It should flow from point to point. Always looking where your next destination point is. There we go. Now I'm going to try and do it as best I can with the marker. And there we go. So there is our curve. Now what we want to do is I'm going to get the triangle. Very easy to get the triangle. There's a little 5 millimeter gap. Okay, and it's in line with point G out here. So to get the triangle, very simple. From here, just do a little line up. Excuse me. So from there, just do a little line up from here, a line out. From A, I'm going to extend the line out here as well, just a little bit. And then there's a little 5mm gap between it, so mark 5. Do a line up. And then that's simply going to connect down there like that. And we're going to heavy that in. So there's our sail. Okay, nice and easy. Now finally, the last bit of the question is this little portion down here. Now this bit is easy. It's just a case of coming down 30mm, going out 15 to get that little bit. So we'll get that little bit first. So from D, I'm going to measure down a distance of 30mm. Down 30, make a little mark. Do a line out. And then from there, out a distance of 15. Do a line up. Get this and that. Now, what they tell us to complete this question is this, on this specific part. And I will highlight it. It tells us here, the curve LM is an identical portion of the semi-ellipse CDG. So what they're basically saying is, that curve that we have to get here has the same curvature of this curve here. So how can I take this curve here and put it over here? Or like I should say that curve, whatever way you want to call it. So what I do know is the measurement that I need, which is 30mm. That's how much I want. And I might, look, you'll actually see here, if I zoom in, it goes a little bit further than the 30. So the 30 is there, but the curve continues on a little bit. Because they do tell us, it says here, complete the given design showing clearly how to locate point M. And point M is obviously a little bit further. So I'm actually, instead of taking 30, I'm going to go and I'm going to take maybe 40mm. So what I want to do is, I want to take the portion of this curve and add it on here. So I'm going to take this curve and I'm going to split it up into cuts. So from C, I'm going to do a distance of 40mm, but I'm going to take cuts in increments of 10. So from C, I'm going to go 10, 20, 30, and 40. Now with those cuts, I'm going to draw lines down like this. 40, at the 30, at the 20, and at the 10. Now, with those distances, I'm going to replicate them over here. So from here, think of this is where your ellipse starts. That's like point C again. Now in this case, it's point L. But the same concept, I'm going to measure in the 10s. So 10, 20, 30, 40. 10, 20, 30 is there already. Here's the 40. Now from the 10, do a line out. From the 20, do a line out. From the 30, do a line out. And 40. And what I'll do is I'll take the same distances. So I'm going to take the distance from here to the point on the curve. That little distance there. That's at the first 10. I'm going to mark it out. Now I'm going to take the distance from the 20 to where it cuts the curve right there. Should probably do it this way. That distance there. I'll go up to the 20mm mark. Now I'm going to take the distance for the 30. So that distance there. I'll go to my 30mm mark, which is a point D, and finally the 40. Because it'll match up, and I'll go up to the 40mm mark. And all I do now is sketch in that curve as neatly as I possibly can. And the reason, because we don't want to stop here, I needed to know where it was going. So now I can find exactly where point M is. Okay, and at this point now, put little marks on them just to make them stand out. Not heavy as far as there. Okay, so there you have it, guys, and that there is L, and I think it is N. There's the 2 points. So there you have it, folks. That there was one of the junior cert questions from the old paper at higher level, and you can clearly see that was our challenge and we're after completing it. So there you go, folks. I hope you found that helpful. That's the video done.